Students, we've covered molar mass. We are now going to talk about molar volume. Now, for those of you who have never heard of molar volume, don't worry about it. We're going to cover it right now. With definitions, as you know, the previous videos, I don't really like to memorize them. What I'd like to do is to understand the calculations and form my own definitions. So before I give you the definition of molar volume, let's look at what it means. Molar volume is equals to the volume of a gas divided by the number of moles. So, what does this mean? The volume is always in the unit of decimeter cube. Okay, why? I wish I knew, guys, but anyways, it's always in the unit of decimeter. What does decimeter mean? For those who don't know, 1 decimeter cube equals to 1,000 centimeter cube. So in a question, if I give you the volume and the unit is in decimeter cube, don't worry about it, you just take that value. But if I give you the volume to be, for example, 120 centimeter cube, I will have to convert it to decimeter cube. How do I do that? What I'll do is 120 centimeter cube divided by 1,000. Okay, you always divide by 1,000. To convert centimeter cube to decimeter cube, take the value of centimeter cube and divide by 1,000. So in this case, 120 divided by 1,000 equals to 0.12 decimeter cube. Now, molar volume has a fixed value. That fixed value is 22.4 decimeter cube per mole. This is the value of molar volume, and this is at a particular condition. That condition is called STP, which stands for standard temperature and pressure. This value, I think you should memorize it. Sometimes they give it students, but let's not take a risk. So molar volume equals to volume over number of moles. The value of volume has to be in decimeter cube. 1 centimeter cube equals to 1 decimeter cube equals to 1,000 centimeters. So we know how to convert, and the value of molar volume is given to us 22.4 decimeter cube per mole in STP, which is standard temperature and pressure. Therefore, the question right now is, what is the definition of molar volume? So, molar volume is the volume of 1 mole of gas at standard temperature and pressure. This is the definition, and try to memorize it. I don't think this is too difficult. Now, remember what I said about molar mass, guys. I'm just going to go back to molar mass. The link was always the number of moles, right? The same thing with molar volume, guys. The link is always number of moles. So I'll write down the formula here. Molar volume equals to volume over number of moles, and let's start doing questions. Okay, see how it works. So first question, what is the volume of 0.3 mole of sulfur dioxide gas at STP? Now, this is sulfur dioxide, so the chemical formula for sulfur dioxide is SO2. We have the mole of this, mole equals to 0.3, and we want to find the volume. We're given the, are we given the molar volume? No, but we know it's STP, and remember I said the molar volume is always fixed, 22.4. So that's it, guys. Plug in molar volume is 22.4 equals to, we don't know the volume, so X over number of moles, which is 0.3. To find the volume, you just cross multiply. 22.4 times 0.3 is 6.72. And what is the unit of volume? Decimeter cube. Good job, guys. Let's continue. Next question. And I'll just write the formula down. MV equals to volume over moles. Always remember, volume decimeter cube. If you have to convert, you convert. Next question. Find the number of moles of oxygen gas contained in a sample of 120 centimeter cube of the gas at room conditions. Now, okay, let me think for a second. I have oxygen gas, that's O2. I want to find the number of moles. So, number of moles, this is the question. Put a question mark. And I have the volume, which is 120 centimeter cubed. But hold on a second. Hold on a second. Let's not, get excited. 120 centimeter cubes. This is the issue. We need to convert this to decimeter cube. How do we do that? From centimeter cube to decimeter cube, divide by 1000. So 120 divided by 1000 is 0.12 decimeter cube. Now you have the volume. You need to find the number of moles. You know the molar volume is always going to be 22.4 equals to the volume, which is 0.12 decimeter cubes, over number of moles, which is x. So 22.4 x equals to 0.12, and x equals to 0.12 over 22.4, which is equals to 0.00, let's see, 1 second, guys. 0.12 over 22.4 equals to 0.005357. Now, in some questions, they will give you the molar volume. You don't always assume 22.4. You assume 22.4 when they say STP, standard temperature and pressure. If they don't mention STP and they give you a value of molar volume, you use that value of molar volume. Okay, guys, I hope that's clear. Okay, guys, now we get to the really fun part. This part is where we are going to combine everything. Number of particles, Avogadro constant, molar mass, molar volume, everything becomes one. Big examples. Let's go. I'll just write the formulas down. Molar mass equals to mass over mole. Molar volume equals to volume over mole. And to convert from mole to particles, I'll just write PART. You times Avogadro constant. Avogadro constant is N sub A. From particles, to get to the number of moles, you divide Avogadro's constant. And remember, guys, it's not always the same for molecules as it is for atoms and ions. Remember all this? Now let's go. Question. Calculate the number of water molecules in 90 grams of water. Okay, so water is H2O. We want to find the number of water molecules, which is the particles. We are given the mass, 90 grams. Mass is 90 grams. So, to get the number of particles, what do we need? Always the most important thing, guys, number of moles. So, can we get the number of moles from here? Obviously, we know the molar mass of water is 18. So, 18 equals to mass, which is 19 over mole, which is x. 18x equals to 90. X equals to 90 over 18. So, the number of moles equals to 5 moles. Now that we got the number of moles, we want to get the number of molecules, which is the number of particles. So 5 times 6.02 times 10 to the power of 23, and that's it. We get 3.01 times 10 to the power of 24 molecules. That's it, guys. Do you see how fun this is? I hope you guys are having fun. Write these three formulas down, guys. We're going to do some more questions. Let's see how many questions more. 1, 2, 3, 4. Yeah, just 4 more questions. So if you can do all these questions, definitely going to get full marks on this section. Let's do this, guys. Next question. What is the volume of 24 grams of methane at STP? So the keyword at STP, immediately we know molar volume equals to 22.4. Volume of 24 grams of methane. So the chemical formula of methane is CH4. We want to find the volume. Do we have the mass of methane? Yes. Mass equals to 24 grams. To find the volume, let's think for a second. What formula has volume? Yes, molar volume equals to volume over mole. I have the mass of methane, but I don't have, let's see, obviously link, guys, think link, number of moles. Can I get the number of moles from here? Yes. Do I have the molar mass of methane? Just calculate it. The number of, let's see, the mass of carbon is 12, the mass of hydrogen is 1, but multiplied 4. 4 times 1 is 4, 4 plus 12 is 16. So molar mass, which is 16, equals to mass 24 over number of moles x. 16x equals to 24, x equals to 24 over 16, x, which is the number of moles, equals to 1.5 moles. Bring these moles over to this equation now, because we are trying to find volume, right? STP, that tells us that molar volume is 22.4 equals to volume, which we need to find, x, over number of moles, which is 1.5. So to find volume, 22.4 times 1.5 equals to 33.6 unit. Centimeter cube? No, decimeter cube, guys. You see the link, guys? 3 more questions to go and we'll be done with this. So, how many aluminium ions, the word ions, okay, are there in 20.4 grams of aluminium oxide? Aluminium oxide is Al2O3. And we want to find the number of ions, which is the number of particles. So remember, Avogadro constant, number of moles to find the number of particles times Avogadro constant. But we need the number of moles. Now we have the mass of aluminium oxide. Mass equals to 20.4 grams. Can we get the number of moles? Obviously, mass divided by molar mass. Molar mass, what is the mass of aluminium? 27. 27 times 2 is 54. Plus, mass of oxygen is 16. 16 times 3 is 48. So, we get the molar mass to be 102 gram per mole. So 102 equals to mass, which is 20.4 over molar mass, which over number of moles, which is x. 102x equals to 20.4, x equals to 20.4 over 102, x equals to 0.2 moles. So we've got the number of moles. Now we want to find the number of ions. So 0.2 times 6.02 times 10 to the power of 23. And we are done, right, guys? No. Think, guys, think, read the question. How many aluminium ions? Remember the rule for atoms and ions? We have to see how many we have. We have 2 ions of aluminium, 3 ions of oxygen. and we want to find number of aluminium ions. So multiply this answer by 2. If it was just molecules, it would be 0.2 times 6.02 times 10 to the power of 23. You get it, guys? Multiply this, what do you get? 2.408 times 10 to the power of 23 aluminium ions. You get it, guys? Awesome. Thinking critically. We're almost there. 2 questions to go. Okay, second last question. Calculate the number of hydrogen molecules contained in 6 decimeter cube of hydrogen gas at room conditions. So, and they've given us the molar volume to be 24 decimeter cube per mole. This is not STP, guys. One more thing, if molar volume is room condition and it's not given, it will be given, but just so you guys know, molar volume at room condition is 24 decimeter cube per mole. If it was standard temperature and pressure, it would be 22.4 decimeter cube per mole. Okay, guys, so now back to the question. Let me just X out of this. So we want to find the number of hydrogen molecules, which is the number of particles. So think, the goal is to get the number of moles and then the number of moles times Avogadro constant. So one step at a time. How do we get the number of moles? We have the volume, right, of hydrogen gas. So molar volume equals to volume over mole. We have molar volume to be 24 because it's room temperature, equals to volume, which is 6 decimeter cube. No need to convert because it's decimeter cube over mole. So to find the number of moles, 6 over 24 moles equals to 0.25. We've obtained the number of moles. We want to get the number of hydrogen molecules. So moles times excuse me, times the Avogadro constant, which is 6.02 times 10 to the power of 23. That's it. 1.505 times 10 to the power of 23 molecules. If it was, because this is hydrogen gas, if it was number of atoms, this answer times 2. If it was ions, this answer times 2. You're getting it, guys. You're getting it. Last question. Woo! Find the volume of nitrogen in centimeter cube at STP, at standard temperature and pressure. So we know molar volume is 22.4. So sorry, let me reread the question. Find the volume of nitrogen in centimeter cube at STP that consists of 2.408 times 10 to the power of 23 nitrogen molecules. So we've been given the nitrogen molecules, which is the number of particles. We want to find the volume. So when we find volume, molar volume equals to volume over number of moles. We want to find the volume. We have the molar volume because it's an STP, so that's 22.4. The only thing missing is the number of moles, right? But we have the number of molecules. So from the number of molecules to get the number of moles, what do we do? Think, guys. From number of moles to number of particles times Avogadro constant. Now number of particles to the number of moles. You divide Avogadro constant. So number of molecules 2.408 times 10 to the power of 23 divided by Avogadro constant, which is 6.02 times 10 to the power of 23. We now get the number of moles to be 0.4 moles. We want to find the volume. So molar volume, which is 22.4, equals to volume, let's say X, over number of moles, say 0.4. So X equals to 22.4 times 0.4, which equals to 896 decimeter cube. Always the unit is going to be decimeter cube. That's it, guys. Congratulations. You're done with molar mass and molar volume and all this good stuff. For the next part of the video, we're going to talk about chemical formulae, how to write down chemical formulas. Very interesting. Things will start to make sense even more. We'll talk about empirical and molecular formulas, some calculations, and how to balance equations and do some calculations. You're then set, guys. So stay tuned and thank you.